Welcome, everyone. My name is Alim Ghaffar. I am the organizer of the Meteor NYC meetup and a principal and data scientist at Dira Market Dynamics. At Dira Market Dynamics, we help businesses solve their market discovery and development problems with the strategic use of data and technology. This is Lunch and Learn, a midday virtual workshop for hands-on learning. We'll be doing some housekeeping before we move on to the event. Now, this meetup used to be called Apollo Meteor NYC at the meetup.com site, yet our notices have used Meteor NYC. Well, change is afoot. If you sign up to join this meetup, you can do so at meetup.com. And let me do this, okay? Okay. We host virtual events here at meetups.meteor.com, which is built on Pathable's conferencing platform. This platform is an example of a large real-time system built on Meteor. We will be building out our community presence here as well. So, as I said, I organize this meetup, but I also organize two data science meetups, Data Science Panel and Data Skeptics. And I'm starting a new developer community with Justin Krupp called High Impact Tech. Now, if you don't know Justin, he is an engineering manager at Snap and is one of the authors of Meteor Now and Meteor Heroku, both open source projects. If you're interested in learning more about high impact tech, let me know and I'll get you on the mailing list. If you're interested in speaking, presenting, demoing at any of our events, I'd like to hear from you. If you're interested in helping out, let me know that too. And if you're interested in sponsoring our events, I'd love to discuss the opportunity. Use the information in the slides to get in touch with me. I encourage you to join the Meteor forums and Slack community to get the most out of this global resource. Both are active with members willing to help you get acquainted. The URLs for both can be found on the slide. Meteor Software has sponsored this event with some swag. I'll announce the winners of 3 bits of Meteor swag, mugs and stickers based on your participation today in the chat. So get some questions into the chat for Jan. And with that, today I'm pleased to introduce Jan Kuster. Jan comes to us from Germany. He is a software engineer at the University of Bremen. He writes often about Meteor and is deeply involved in the community on forums and on the Slack where you can find him. Welcome, Jan.
Yeah, thank you, Alam. Thank you. I'm pleased to give this workshop today. Which is basically just a reflection of what I learned when I worked on Meteor Microservices. I also prepared a little presentation to start. So let me share my screen with you. So Meteor and Microservices. When I started working on our project with Meteor, which I also showed at the Meteor Impact 2021, by the way, there was one point where I asked myself, is Meteor a good choice for microservices? Because at that time, it was about 2016, that was a very hot topic. Microservices was everywhere. When you looked at the web, it was the hot new stuff. And Node was a very good fit for microservices, but I wasn't sure if Meteor was a good fit for microservices because I knew Meteor as this super holistic, full stack framework, can do everything and has this isomorphic code. But I wasn't sure if I can do tiny, headless things with it, lightweight, not resource hungry, and no client involved. And I found out that there are ways to do that, and it's much easier than I thought. I have been already introduced, so I will skip this slide, just keep it for the info afterwards. Just a small reminder on microservices. I know these things are still debatable, and there are different opinions about what microservices are, what they're not, where they start, where they end. From my point of view, I see them as narrow scoped applications, mostly just one scope, sometimes a few scopes, They're independent from each other. That's the most important thing. They're standalone running applications. They're not coupled to each other. In the best way, they are self-contained, have their own database, and just exchange data via communication channels. And this has obviously big advantages. You can scale them in both directions. You can either put more resources on, scale vertically, or you just add more services and scale horizontally. And the best thing is, while a monolith has to be scaled all over, in microservices, there is only that service scaling that is on demand. So the other services keep a low profile and you have a lower resource profile. But besides that, I have prepared a very, very, very simplistic example here, but I hope it's simple yet understandable enough to get into the topic. Just imagine you have a typical shop software, some e-commerce software, and this shop software uses some kind of catalog. And often these catalogs, they are maintained by sometimes by some people and sometimes even by some services. And big retailers, they often have their own warehouse, or they have some externals that run a warehouse. And if you want to give your customers an idea of how many products are available, then you need some kind of connection to that warehouse. And obviously you don't want to ask the people there manually, like, hey, is this product still available? But you want to automate that. And this is where we focus today on. We create two small services, a catalog service and the warehouse service. And sorry, that was too fast. And they will communicate with each other. Now, there is one thing, and that's what will be after the communication part. That's the biggest issue I had when I started into this topic, is not only how to communicate. That's fairly good documented with the DDP connections and all stuff. I will show you that later. But there is one other thing, and that's authentication. Because when I just do a direct connection between those services, they can share everything. Everybody can, if the service is public, everybody can, who knows the endpoints, can request resources, can write resources if this is available. And this is something we don't want to do. And there are some issues there, because the classic way Meteor provides authentication is via accounts. And some of you already know I gave a talk in 2020 in the Impact conference on OAuth and your custom OAuth server, and that's all cool and great, and we can have users across all your applications. But what if your applications want to talk to each other without any user involved? So then we obviously can't rely on accounts, and you don't want to create some kind of fake account in behalf of that. You will create requests and all that stuff where you have to manage an additional account for that. So I looked a little bit in the web and also read on authentication, several authentication methods, and JSON Web Token is something that fits perfectly to that. It's basically just an encrypted JSON file with some claims on resources. So claims, resources, something you heard maybe from the REST universe somewhere. So you can make these requests with your token and describe in detail what kind of resources you want and not. You can secure your API there, not only from a main perspective, but you can secure your different endpoints. That's cool. So if it's valid, if the request is valid, it can consume this API, otherwise not. So you can create different validations for different endpoints without any users involved. Just as a visualization of how this will look like when we will code, we want to have our catalog connect to our warehouse and ask for available products, keeping very simple. Warehouse will have a list of products that are still available, not even counts involved or something, just what are the available products. And the warehouse will only return these available products when the JSON Web Token handshake, basically, I can call it handshake here, is valid. And we will use Meteor settings to store these secrets. For those who are new, with Meteor secrets, you have a way to secure API keys in your deployments and without leaking them, unless you check them out to your repository, which would be not that good. But we will store the keys and all that stuff in the Meteor settings and then see how that works out. So hands-on, everybody get your IDEs ready. I tried to make this in a way that you can follow up. So I'll do actually a live coding. So I've created an empty directory called Microservices, and I will create the services now with Meteor. But I will not use the typical Meteor project you create, like Meteor create and then project name, but we want to create a bare project. If you, for example, type Meteor create -- help, you will get a list of all the options. And then it's interesting, there are some things that are not so present all the time. And there's, for example, the bare example, create an empty app. So this is what we're gonna do first. We create -- a catalog. So this will create our app catalog app. Just rename that catalog. And then I will do the same with warehouse. So both bare apps. And that's there. So I can refresh and then I should be able to see those two, catalog and warehouse. When I take a look inside them, then I can see nothing besides a .meteor folder, which contains the builds and the node modules and package.json. So it's really bare. It doesn't contain anything. It doesn't even contain an entry point. So we have to even add this entry point. You can do that by, I'm doing it by creating a new directory called server. And then in the server folder, I will create, yeah?
If you don't mind, could you make the text a little larger? People are having a hard time seeing it.
Yes, we can do that.
Thank you.
Sorry for that. I should have done that in advance. Let's take 18. That looks better from the IDE perspective than just going on the editor. I think there should be font size. Let's use 18. Yeah, looks better. Okay, good.
Is that better? Okay, yes, I'm getting a response to that. Yes, it is.
Okay, that's good. So in the okay, just recap. I've created a catalog project as a bare project, and then I want to create an entry point because that obviously doesn't exist. So I create my file server /main.js. And that's the second thing. I need to open the package.json. And as you can see here, there is no entry point defined. So we add that by adding Meteor, and then an object, then main modules, or main module. Let me check if it's main module or main modules before I say something wrong. It's main module without S, main module. And our main module for server, because we only have a server entry point, we don't have a client here, and I currently have no tests added. So it's server /main.js. And if you compare that with a typical Meteor project you create, then you will see it's already, this is already there. I just want to start it from a total empty app at this point. Okay, so this is a bare app, but let me show you something. If we go into the .meteor folder and see what packages we have there, then you can see that there are still packages we even don't need for our microservices, because it's really just server side now, and it's a system service, I would say. It's not something that is bubbling up to the client. So we don't need mobile experience. We can remove that. We will need Mongo, or may need Mongo. I mean, that's basically our database here, so I would keep that. We don't need static HTML because I don't want to send any HTML to the client. We will not need reactive variable, and we don't need tracker, so we can remove that as well. And we don't need the standard minifier for CSS, because on server, obviously no CSS involved. ES5 shim, so the compatibility for older browsers is also not required on our server, because we have the node environment.
Could you just mention what tracker and reactive Vars was,
yes,
just so that people that are not familiar with?
Tracker and reactive variable are main components for the reactivity in Meteor. So they are, especially tracker is the core component of making reactivity possible. So that's this nice automagical update of your data on the client when you have subscribed, for example, to something, and then your collection changed on the server, and then with your publish and subscription mechanism, it's automatically sent to the client. And tracker is that what will help your client to automatically redraw. So that's the client part of the live updates, I would say. But on the server right now, I don't introduce any live updates here right now to any client, and on the server I don't need that, because I don't want to draw anything. I don't do server-side rendering or something, so I just remove them. And I also remove ES5 shim because I don't need older browser compatibility, and I also remove the shell server, because shell server is something on development. You can, when you have a running app, you open a new window, a new terminal on this, go into the folder and say Meteor shell, and then you have an interactive shell like a REPL. But I don't need that for right now. So this is the most, and the standard minifier CSS. So 5 packages. That's the most minimal I can get for right now. And as you can see, this is just a way different footprint than before. And it's running. So you can just go into catalog and into Meteor, and then it's running. And while it's starting up, in the meantime, I will do the same with the warehouse. So to remove all these packages we don't need now. Mobile experience, static HTML, reactive variable tracker, standard minifier CSS, ES5 shim, and shell server. So removed. I will create another entry point. We'll keep it the same, server main. Now I can just copy the entry point from here to save some time and prevent some typos. So it's basically same server main.js. And now I need to run this now on a different port, because we can't run both services on the same port, obviously. So I say Meteor minus port equals 1000. So my catalog is now running on 3000, and the warehouse is running on 4000. So what we're going to do now is connect them both. We let them talk to each other. And since the warehouse, or in our use case, the warehouse will request data from the catalog will request information from the warehouse. So the catalog will be the one that will do the connection, that will connect to the warehouse and request things. And in order to connect a Meteor app to another Meteor app, you use a DDP connection. That's, by the way, the same connection that your Meteor client package will use to connect to your Meteor server. It's just baked into your Meteor namespace. So in order to do that, I'm importing DDP from Meteor/DDP client. And I want to connect that now. I will show you how to do that. I will do that on startup, Meteor startup. And on startup, I create a new connection, ddp.connect. And now that will be the URL of our warehouse, and that's localhost 4000. You can also take a look in the docs. DDP connect. There is it documented. And what I will do, what is not documented yet, but will be soon, I will add some more options here. And in these options, I write unconnected. That's a callback that will automatically be called once the connection is established. And I want to write console.log connected to warehouse. So I'm just doing that. Oh, and it's already connected to warehouse. And I show you something now. Any one of you who already wrote code with Meteor knows that when the client has no connection to the server, it will attempt to reconnect. That's actually the DDP connection. So it's the same on the server, from server to server. So when I just close this, it will tell me it's disconnected, or it can't connect because there is nothing running on 4000. When I run that again, does it work? Oh. Okay, maybe it's already timed out, but if I'm fast enough, it would reconnect usually. So when it's running, and now it's running this. Okay, then it's still connected afterwards. Maybe there's some tweaking required, but you can, that's a big advantage here. You can tweak your connections and your services in a way that when there's a time, when there's a connection timeout, or there's some disconnection between the services, service failure or something, you can just easily configure them to reconnect until they work again. So this is also an obvious important feature when dealing with microservices. I have now my catalog connected to my warehouse. Just rename that. And on the warehouse side, I need to do some things now, because the service is connected, but it needs to get some data. And in order to do that, our warehouse needs to provide some data, actually. So the warehouse, I will just create now some easy example, or simple example. Just assume our warehouse has a collection named products. It's a Mongo collection, very simple. And let's say on startup, we just want to add some products. We just want to add some example data here. So say just a for loop of 10. And then just say some are available, some are not. or maybe we do not 10, but we do 25, because with 10, I already had tried this out. I had one time that my random generator made all unavailable. So we just create a random available status, math.random bigger than 0.5. Math and random is between 0 and 1. So chances are 50% that it's available or not. Good for a Boolean. And we have some title. And for this title, I just use random.id, let's say 8. That's an internal Meteor package, but it's actually quite good to add some faking data sometimes. So I just added that, and then I say products.insert title and available. So these are, so now we added these products. Some will be available, some will be not. And of course, we need a method now. That's cool. That returns only the available products. So we call that available products. Sorry, I was a little bit fast. I just created, I just used Meteor methods and then passing an object with names and then functions for this product, for the Meteor methods. There are different ways to create methods, and this is not the best way to create methods when you're running on production, of course. Then you should use a validated method for doing much more like extended validation, adding mixins, and for logging, for anything you can imagine. Even for microservices, that's actually very applicable. But I will keep it here on Meteor methods because it's simple, and we want to keep it simple here. So our available products is a function that returns what our product collection can find, but with the available to set to true. So we only want the available products, of course, and we need to fetch that. Very important. If you return the cursor, then you will have the problem that it will throw an error because you can't return a Mongo cursor to over the wire to some external application. You need to fetch it to get actually the data and return it. So if we have that until now, available products, it will rerun, create something. If we have this method set up, we need to call it, obviously. So back in our catalog, I will just split it so you can see what happens on both. I think that's a little bit easier. Back on the catalog, we want to do a Meteor call, not a Meteor call. Oh, that was too fast. I don't want to do a Meteor call. I want to do connection.call. That's actually the same as Meteor.call because, as I said, the connection is baked into our client Meteor, but here we want to say connection.call, and then the name. And the name is, as I said, available product. And then, without any parameter right now, error and our products. And then I just want to list them. So if there is an error, I want to do console.error. And then I want to do console.log products. Or say available products. And then it's getting back. Okay, let's find out if that works. Oh, there are some, as you can see. So that's actually now already our basis of microservices. We have these two running services with minimal setup, connected to each other and communicating with each other. As I said, there is the problem that with this setup, anybody who creates such a service knows the URL, knows the endpoint, can make a request. Gets even worse, this great feature we have with the automatic reconnection, this is also at the same time a threat, because this automatic reconnection makes it problematic to just disconnect them. You can just say, oh yeah, you connected. There is a way to detect if something is connected, by the way. That's on connection. So I can say Meteor on connection. I can just do that now. Just add it. You can see Meteor on connection function remote. And just logging the remote so you can see what's going on there. You see, so that's the remote that's connected. I could now run on this remote. I could just run this close method, but if I would do that now, it will just try to reconnect, and this function again will try to close, and then it will reconnect, and that will just blow everything up. So that would be, if you have that problem, that there is something connecting that shouldn't connect, that would be something what you level up to the infrastructure level, blocking the IP or something like that, Cloudflare, whatever you're using. I'm just keeping it here for your information, that you know it exists, that you know that you can use this information and act based on a scenario. At the same time, our catalog would be a little bit larger now, because on every startup I'm inserting so many documents here. Okay.
Don,
Yeah.
there is a question. It says, regarding DDP between microservices,
Yes.
what about scalability? If we have 5,000 users, for example.
That's actually a scenario I haven't faced yet. I can't say for that. There's, in the end, what I can tell you is the scalability issue is still the same as you have a typical Meteor application, because, as I said, it's the same way as your Meteor clients connect to your Meteor server. The difference is you could do, of course, you could start doing clustering. You could start also. It's the same mechanism as you would do with a typical Meteor application. You could start clustering. You could try to throw more resources on it. You can try to avoid publications as possible. I mean, publications is always that bottleneck topic that many people have. The good thing with microservices, I think, is that you can try to separate the process that is resource hungry into an own service, and then scale only that service. I think that's the biggest thing you have to consider here. Just think about, you have one application, you have a Meteor application, and the Meteor application is now a classic monolith, but you have one process in that application that is very resource hungry, and it's only that process. You could try to isolate that process into this external service, run everything via DDP, and then you have extracted this resource hungry process into this external service. It will still require resources, it will still be a problem, but your Meteor application will manage all the connections, and the resource hungry process will be only connected with your Meteor application. That could raise another bottleneck issue. So it's a bit up to you how you design that in the end. That this is also something that in the microservices world always is a little bit troublesome. What is the right setup for which scenario? There are also thousands of opinions on that. Just saying, summarized, you have to think about publications. You have to think about document size, and you have to think about splitting up the services in the right way to distribute your load. But this the laws, or I said the laws, the technical side on this server DDP connection is the same as if you have a Meteor application and you have 5,000 users connecting to your Meteor server. I hope this helps a little bit, or that this gives some kind of clue how that goes.
Yes. The questioner has thanked you for that. I do have one other question, which is this automatic reconnection, doesn't this create almost a, unintended denial of service loop?
Yeah, that's
Potentially.
what I mean. Yeah.
Yeah. And, in many other cases, you will typically code into your service a back-off strategy for connections. Is there a way to do something like that with Meteor?
So you mean to prevent any connection incoming? Actually, I don't know that for sure. And the question is if that even exists in the code. But I think because it sits on top of some WebSockets, I think there should be ways to implement that actually. I didn't face this scenario yet because for us, we have it set up like we have a public Meteor App that connects to the services. So in the services, you can put back actually you can still put that in private networks, or you can have firewalls or anything like that. So there are different setups you can use right now already, but I'm not 100% sure if that's possible to have this back-off strategy. So in my case, I would do that here, something like, that would be very naive approach, but it would be possible, like having like count, and then for each connection of certain IP, you count up. And if this IP still tries to reconnect for the something X time, I would let the infrastructure level handle that, like giving that to the guys from the infrastructure network department and let them handle that on, I don't know, load balancer or whatever level they are working on.
Sure. So there is a user that just made a comment. Typically, microservices run on private networks.
Yeah, that's the thing. If you have something that's just internal usage, you will just have this running on the private network. There are still some things like micro front ends where you can create some kind of microservices that still returns some very simplistic or reduced HTML to your application that it will have to be, to some extent, be public. So then this may become an issue. But apart from that, if you run these on your private networks, then you have a little bit more control, of course. Something more? Or
that's it right now. We're good.
Okay. So we're now at this point, they're communicating with each other. And now we want to get into adding some kind of validation. And I'm doing what I'm doing now is I'm not implementing any JWT validation or something. I will, of course, use an existing library. It's up to you to choose a library, to validate the library, and something like that. Everything that's everything where authentication mechanisms are involved is up to you to review and audit their code. I'm also not affiliated to the library I'm introducing. I just wanted to use something that's stable and that's presentable. So what we want to do is we want to add to this Meteor method some kind of validation function, like validate token. And if this token is invalid, it should throw an error. If you use validated methods on Meteor, you could put that in the validation part, then it would run even before this function is executed. It's even more safe. For this example, I would add that here. And in order to add this validate, and we need obviously the parameter token to be sent from the catalog. And in order to do that, I'm just installing the library in the warehouse. Install, it's called njwt, Node.js Web Token. Just install it. And I will create this validation function here just as an inline function. Validate token equals function. So doing that as a self-executing function, keeping everything inline, importing njwt from njwt, and then for as I said in the documentation, in the presentation, I said we want to run, we want to get the credentials from our Meteor settings. I will do that in a minute, but for now, just to get this running, just want to have just writing that down. Meteor settings. So I'm just creating that settings file right now in the warehouse, of course, settings.json. And in the settings file, I want to put some, just need to see if I don't want to do any typos here. I'm adding an object called JWT. Note that this is private, so if you have a Meteor application that also involves clients, then this would not leak to the client, of course, because only to the client, everything that's in the public, in the public object would leak to the client. So beware where you place that. If there's no public, it will not leak. And then we need a JWT key that's used for signing, and so for signing and for unsigning. Because your JWT will be basically encrypted, and so you need to decrypt it later on. And for your handshake to work, the keys need to be the same, obviously. There are setups where you get these keys from a third party and a key authority. That will obviously be too much for this example right now. So I will use this super secure and non-guessable key here, and also add some information to our catalog app. That because there could be many externals asking for a resource, and then I want to split that a little bit. Like, for example, some requests may be from different services, so I store what's the URL, what I expect here right now. You don't need to write that down. You don't need to add that. I'm just adding that here so you can see that that's also part of it. You can even add some kind of, they call it subscriptions, but it's not the same as a subscription Meteor. It's like a topic, or not subscription, sorry, it's a subject. So our subject here is services catalog. You can also use the method name as a subject. I do that, for example. And now we want to use this information to validate our token. So our validation token will actually be the token. Or actually, we can add the method name as well, just showing you as an example. So first thing, if no token is added, we throw an error, basically. So throw new Meteor error 403, permission denied, and as detail we say no token. So can already start on that if we want, and in order to get the right error, we just save that, run here, and then you see already when the apps are rerunning, will tell us permission denied, no token. Okay, let's add some fake token here. Yeah, that will of course pass because we haven't validated the token here. So what we need to do now is we need to use this NJWT library, or that's what I use in this example, to unseal. First we need to unseal it. if there is an error during unsealing, for example, the token is outdated or it's simply invalid, I will wrap that error up and then return the same 403 permission denied error, but with a unified message. So no matter what, unseal is NJWT, and that it has a method called verify. No, not every, verify. And then we just add the token and our key. And the key, that's what we stored here in our Meteor's settings. That's the key it will use to unseal. Oops, that's not what we want to do. We want to add that here. So if this unsealing process already raised an error, we just want to catch it and want to throw our own error called invalid token. So just doing that here. And now you can see now it's saying not no token anymore. It's now saying it's a permission denied invalid token. And now we can even go to further details. So if we have this unsealed token, it will contain a header and a body. In the header, there are informations about the encryption algorithm and the I think the encoding or something. But what we want to use now is the body. So there will be 3 things that are interesting for us. It's called scope. We will use this scope for the method name. Subscription, something like a subject. I always confuse them. Subject and the issuer. We get that from unsealed.body. What we do now is if scope is not our method name or the issuer is not our catalog URL or the subject is not our catalog subject or something like you can think of as a user or a unique user ID or something, but we don't have actually users here. So the subject is something more synthetic, like services/catalog. It's a broad idea here. So if this is not working, we just throw the same error, invalid token. And then in the end here, pass this, do nothing. And then we can change that. So now we can't do any requests here because we always get permission denied because we don't have a valid token on the catalog side. So in order to create the token on the catalog side, we also need to write a function that uses this key and these credentials, builds the token and adds it to the request. And in order to do that, I remove this fake data and just say token equals create token. And we will need some more information here. So we need, oh yeah, and I said I want to add the method name as scope. So we can actually scope on the method level. But besides that, the rest of the information is the same. And we do that similar as just move a little bit down here. Do that similar as in the warehouse. Just do that a little bit. So it's so I hope it's a little bit easier to read here. So it's similar. We write a function. Now it's called create token. I like to do that in a inline function, so it's all put into this own function. We will need again this Node.js web token, which we need to install in a minute. Maybe we do that right now. That would be good. So just go one level up, go to the catalog, set Meteor npm install -- save and JWT. Oh, what's wrong here? Typo and JWT. Yep. And then we can continue here already. No, there was one thing I missed, sorry. We also need to store the credentials here as well. So we use the settings.json for the catalog. And the catalog settings are again the same key as I used here. So it's my super safe, super secret key. And it needs to be the same. If it's different, then it will obviously throw. And we want to do the same subject. We want to run on the same subject services / catalog. And we create that like, first we want to get the key and the subject from our Meteor settings. So Meteor settings.jwt. And then we return the function with method name as parameter for the scope. And then we create this JWT with the library. JWT is no JSON Web Token create. And this now has some, allows some options here. We can define, and that's these resource claims I talked about. So we can write this scope. We use scope method name as scope, a subject, the subject we just got from the settings, and the issuer is an URL. As I said here, it's the localhost URL, and as the URL, we make that easy. We just write that once. We can use this nice feature, Meteor Absolute URL, that will give you always the URL of the current running application. Now I'm not sure if that will work out the same way if it's running on a private network. There you may need some different things, but the good thing about JSON Web Token is that these are just simply informations you put on a conventional basis. So there's no pre-configuration that you now need to put exactly some kind of URL inside here. So you will be good by using any other information. It's just the scheme here. And oh yeah, and we need the key obviously to seal the token so that it's encrypted. That will seal our token. And one important thing, we want to put an expiration date here. We we don't want the token to be valid for a long time. So set expiration. And as we just add a date, so this requires a date time in new date get time from now plus I say 1 second. Don't know if that will be something working out in reality, but there you can implement strategies if that fails. Just want to add something short here. And then return JSON Web Token compact, making it a, this just adding some encoding to make it smaller, good for keeping the transport size low. So now we created this function here as well. I'm changing that now, and there is some issue here. Of course, we didn't run the application. with the settings. So we need to cancel it and type meteor -- settings equals settings.json. Then there is a permission denied error because our URL doesn't contain the slash, I think. Let's see if that's working now. Still a permission denied error. That's something I missed. So let's see what we have here. The sub 3000 / services catalog. I'm just taking a look if they are the same. Also taking a look if they are the same. They are the same. So what is missing here? Just doing a short debugging, and let's see what's that here. Key sub issue URL, and here let's see what's here. Key sub issue, and then let's see available report services catalog, and we have here. Oh, it's not even reaching to that point. I see. So it's seems to be likely here. You know, key argument must be of type string or an instance of buffer. Okay. Oh, then there's something here in our Meteor settings. Yeah. Oh, yeah. .jwt. So key. That's interesting. Why it can't destructure that? Did I forgot to run the warehouse with the settings? Oh, sorry for that. Settings.json. So running the warehouse again with the settings file. Oh, that looks. Let's see what's going on here. So there must be something I'm missing. There's got a localhost 3000. Localhost 3000. What I'm missing here? Oh, last time it worked so good. Catalog.url. Sub is right. Sub. Catalog.subject scope. Let's do that a little bit different. Key sub issue scope. Maybe there's the scope is written wrong. Products. But the method name here is yeah, I forgot the method name as scope. So should work out now finally. Still not. Just give me a second. Does somebody see it where the issue is? Why I can't see the issue here? Scope. Just writing down that and down here. That's actually something I had some trouble with before. And in the last recording, it worked out so well. Oh, where is that coming from? Method name. Okay. There it is. Okay, fine. Now it's working and it's sending all our available products. So that was a little hassle at the end, getting these details right. So, but the good thing is, as you can see, if there is something not not right, then it's throwing early and it's throwing often, and that's what you want to do, what you want to have in the microservices architecture if you want to have any services running. And yeah, I hope this gave you some idea of what you can do. I mean, there are much more things you can do. There will be also in the Outlook. You can create micro front ends with that. You can authenticate publications, authenticate HTTP endpoints. So this is not restricted to methods, of course. And if you know this from other examples like Express and HTTP endpoints, you know that this JSON Web Token is very, very famous and proven method to secure APIs. And of course, sorry, the fourth bullet was just missing. There's also the possibility to introduce an key authority, so you don't have to hassle with all these credentials here in your settings files. I mean, on a certain scale, this also becomes a little bit problematic. So there are also ways to get rid of that. Also, sorry, I forgot this. Also put the references here, the library of the JSON Web Token. There is actually an article I wrote on microservices, which will be updated after this talk, not today, but maybe tomorrow. And I will also put this code in a repository and will also add the repository. So anyone who is interested in the code can take a look at, use it, and build up based on it. Yeah, I hope it was understandable. I hope the debugging was not too much, and I hope you got something out of it today. Thank you.
I think the debugging was absolutely perfect.
Oh.
No, in the sense that, you know, when you're doing development, you're going to run into problems, and watching you go through the process of debugging, I think, is helpful to others also. So that was neat, and thank you so much. Yeah, folks, this is it. If anybody has any outstanding questions for Jan, and I think there's something coming through. The workshop was really good. Congrats and thanks to Jan for sharing his precious knowledge. And okay. Well, thank you so much for the kind words, Rodrigo. We have a member in the group basically thanking us for putting this event on, and I hope it was instructive. I hope that people were like really excited to take a look at what is often considered just a monolithic framework, and seeing how you can strip it down to almost nothing, and have servers talking to each other as services, which is terrific. I have a question, which is, in a real life scenario where you have these services running, and you said that you do for the University of Brennan project, right? Mm-hmm. You know, are you running them in these services in their own containers?
Yeah, we have a little bit different setup here. Yeah. Okay. We have a different setup because on the university I have not infinity, but I have like very much free computing resources, and so for me I can create a full virtual machine for one service. So this is a total different setup from what people will do on the market or something like this, for example, where costs are much more important than for my setup. So I may not be the best person to give advice on that. That could be expensive for people, but I think that Meteor software has actually good offerings and with scaling as well. So I think there will be from the small tiers to the big ones, there are many options there. So and I think even if you have something just to try out, even the free tier would be able to give you some idea of how that will look like. So yeah.
Well, that's pretty cool. So maybe we should see some people building their own microservices and trying it on the free tier and seeing how that works out. So that'd be kind of a neat thing to watch and see. All right, well, folks, thank you so much for joining us today. And if there aren't any other questions, I'll give everybody their time back.
Take care and all the best.
Look us up at meetup.com for our upcoming events. See the details in the comments below if you'd like to sponsor one of our events.